Hello. Today we will learn storage classes. Okay. What are the storage classes? What they do and how to use in our program. Okay. Let us see that. What are the storage classes? The first is we have something called auto. Then we have something called static. Then we have a register and we have a extern. Okay. These are the four storage classes we will be studying and will be using in our program. Okay. Let's go and learn through a problem. Okay, see, I have defined a function. Okay, the function what it takes a parameter for me. Okay, it takes a number and it declared a local variable called a is 5 and it increases a variable by 1 and what it returns to me. Okay, now if I write like this, what is going to happen? Now, when I call this function, first time when I call, I pass 10. Okay, I'm not using the 10, that's okay. Now, a is 5, a becomes 6, and then what returns 6. Again, when I came out of this function, what is happening? This variable a will be destroyed. What do you mean by destroyed? It will be reused. The memory will be reused by somebody else. Okay. Now again, I call the function. When I call the function, again we pass 10 only. Now, what is going to do is going to create another variable called a. The previous is not there. Okay. Now increase a by 1 and returns a. That means again 6 is going to come. Third time I call the same thing is going to come. Okay. If you look at this, I got the output 666. Why? Because every time when you declare a variable inside of the function, whenever you call the function, the variable will be automatically reinitialized. The previous variable will be destroyed and it will be what in this case a new variable is created. Why it is happening? Because by default, in every local variable, the compiler automatically adds a keyword called auto. Adds a keyword called what? Auto it adds. That's the reason it's automatically getting reinitialized. Okay, look at this. So it is for every local variable, the compiler automatically adds a keyword what? Auto it adds for you. Okay, done. Now let us see here in this case, instead of auto, if I put here in this case for a local variable, I declare a keyword static for it. What happen if I make static? If you make a local variable as a static, the variable will be created only once. Only what? Once. Okay. Now, for example, in this example, when you call first time num, I pass 10. Now, a is equal to 5. First time it created a is 5. Okay. Now, a plus plus a will become how much it is what? 6. Now, return a. 6 will be returned. Now, next time when you call, yeah, it goes, but this statement won't be executed for you. A plus plus, A will be what? 6 already. It became 7. 7 will be returned. Next time when you go, it will be 8 will be returned for you. Why? Because this statement, even though it is inside, this statement will be executed only once during compile time. Look at the output. Yeah, 6, 7, 8. Therefore, the static variable will retain the previous value. Will retain the previous value. Okay. Now, no, sir, I did not put a is equal to 5. What happened? Now, I put only a. What is happening for me? I got the output 1, 2, 3. Why? Because a static variable will automatically have an initial value what? 0. Okay, so now if I make it what in this case, if I make it here right now, I'm going to make another variable in this case. This is called global variable and this is called local variable. A global variable and a local variable can have a same name. If you declare a variable outside is called global, if you declare inside is called local. A local will have an auto. Now, a global, what is the advantage of this global variable? This variable is accessible throughout the program. That means I can access here also. Okay, now what do I mean by that? I can access here also. This a, if I write here in this case, a is equal to 10, this 10 is being accessed here. See, look at this. You can access here. Okay, I want to put a comment and show you then. Whereas this a is not accessible. This a I put 5 is not accessible there. Okay. Now, okay, sir. Now, if I make it again, I have one more a here. A is equal to 2. If I write like this, what happens here? Oh, if the local variable and global variable has the same name, the preference is given to the local. Preference is given to the local only. So it will refer this only. Now, okay, I have created a variable a here. right? Okay, I've created a variable what? A is equal to 2. Now by this what happened? I created a local variable called A and there is a global variable called A. As we said before, the preference is given to the local, right? Now if I say here right now extern here, what is the meaning of this? External means external variable. What do you mean by external variable is the variable no memory for A will be created. This will always refer the global one. It will always refer the global one. Okay. That means if I write like this, if I write here A, even though I have an A inside here, it's going to refer the global one. Okay. Okay. Otherwise, by default, it will refer the local. So, okay, then can I put like this A is equal to 2? Okay, put it and see what is happening there first. You can't initialize an external variable. Why? Because in this line, there is no memory is created. The memory is created here only, right? The memory is created what? Here only. Therefore, what is happening here in this case? External variable, you can never assign a value to it. It's only to say the variable is been declared outside. That's it. It's been declared what? Outside. It's an external keyword is being used. Okay. Let's see here now. I put like this right now. If I say here right now, I'm cutting this down. I'm going to write now in this case integer is equal to 5. I'm going to run the code. What is happening for you right now? 10. Okay, now 10. I'm going to print the XYZ value. So you understand better X, Y, and the Z value. And I'm going to print it. See what is happening. It's 666 because by default, even though I have A is 10, this doesn't matter for me because it always will refer the local. Now what I'm going to do, simple thing, I'm going to write here external. By writing external, you can't initialize. In this case, what happened? There is no A is created. When you say A plus plus, it will refer the global one. Oh, now what happened? You see, what is all? 11, 12 and 13. Why? Because when I call this function, A plus plus will refer this, it is 11, return 11. Then I call A plus plus 12, returns 12. A plus plus return what? 13 for me. Right? Okay. Now look at this. I'm going to say here right now. What is the difference between that? You must wonder that so static also gave the same. No. There's a difference between static and what? Global. So in a global, if I write right now here right now like this, what is going to happen? I'm going to say here right now in this place A is equal to 15. Now what happened in this line onwards? A became what? 15. 11, 12 and what? 16. Why 16? Because when he called, when he called first time, A was 10. A plus plus became 11 was written. Next time we call, A became 12. 12 was written. Now A became 15. When I call 15, it becomes 16 got written here. Yeah? Okay, this is a difference between a static and what a local. If I could have written right now in this place right now static, what happens you see? When I say static, what will happen? This A is different. Okay, so what happened when you say first time when I call A is initialized to 0, A plus plus will become what? A plus plus will become 1, 1 will be returned. The next time when you call A will become 2, 2 will be returned. A is equal to 15. This A will become 15. Now again when you call A will be 3 only. Yeah. Now if I print A value, if I say print F percentage D comma A, if I write it, it will refer what? It will refer the global one. I'll get this. Right? Okay. Now look at this. I'm going to say here. If I write here in this place, if I say here right now, register, what happens? If I declare a variable as a register, the memory for this variable will not be created in the RAM. It will be created it will be allotted one of the registers. Therefore, since it's allotted in the register, there is no address will be allotted. Okay. So what is the advantage of this? If you declare a variable as a register, it can access it faster. It's since where it is there in the where it is there in the memory. Therefore, it can be accessed what? It will be in the register. Therefore, be accessed what? Faster. But you can't declare too many variables as register. If you declare too many variables as a register, what the system does, it ignores it. it will convert automatically register into an auto. It will automatically convert a register into an auto. Okay. Therefore, the output of register and auto will be more or less same only. Yeah. Got this, guys? Okay. Yeah. So let us solve a problem. I'm going to put a problem on this. You write in a notebook and then you see what is the answer is going to come. So just to check your understanding, see what you do. You write this in a notebook and solve the problem by yourself. Okay. When you solve it, you will make a mistake, is not a worry. Okay. To solve it by yourself, then understand the theory behind it, and then after pause the video, after some time switch on the video, then you will get the answer for it. So this is the answer. Just see if you have got it, that's right. If you have not got it, find out why it's happening here. Okay.